Hello, and welcome to Spotlight On, the podcast that brings together business leaders, entrepreneurs, and experts covering a range of topics. I'm Nicholas Barton, founder and CEO of the Barton Partnership. We're an award-winning executive recruitment and consulting solutions firm providing permanent search and independent consulting services across strategy, sustainability and M&A, data and analytics, and transformation and change.
Hello and welcome to the Barton Partnership Spotlight On podcast. I'm Kaitlin Bedford, consultant in the Barton Partnership's US PE practice, and today I'm joined by none other than Sviat Dulianinov, Chief Strategy Officer at Bright Machines, a San Francisco-based software and robotics company. Prior to Bright Machines, he served as the Chief Strategy Officer of Dutch grocery chain SPAR. He has also worked at Bain & Company, serving clients across the United States, Russia, Germany, Ukraine, and the Netherlands. Sviat, thanks for joining us today. Can you start by sharing a brief overview of your career journey to date and your role as Chief Strategy Officer at Bright Machines?
Yes, happy to. Initially, I spent a lot of time in consulting and working across multiples of industries, from air transportation to retail and CPG to education and energy sectors. I started with Bain, and later in my career in Bain, started focusing mostly on customer experience throughout retail and CPG sectors, and then transitioned to SPAR. SPAR is a large grocery chain, originally from the Netherlands, present all over the world. And I joined SPAR as Chief Strategy Officer to lead their business unit in Russia. We managed around 200 stores for SPAR and a few other brands in the portfolio. Part of my journey, I managed a few brands. We also launched private labels. I'd launched 7 brands. We also launched new chain with a new format, like a discounter chain, similar to Sam's Club, and a lot of interesting activity, including digital innovation with delivery and applications and so on and so forth. And then 2 years back, I switched and returned to the United States and joined Bright Machines, also to lead strategy, business development, investor relations, and multiple other buckets. And here, what we do is we build smart robotic lines to build the most advanced electronics that is being used for AI applications. So everything that you can see in the data center, from servers to GPUs to network equipment and data storage equipment, we build our microfactories that build those components and those electronics. I lead, as part of the company, as I mentioned, multiple functions, but focus also on strategy, internal business improvements that we've done in the last 2 years, where we go and how we move in the market, how we work with our investor base, and so on and so forth.
So Bright Machines has a fascinating evolution story, transitioning from manufacturing consumer products like Nespresso machines to developing advanced AI infrastructure. Could you discuss the significant pivot and how the adoption of technologies such as machine learning has influenced your strategic direction and product offerings?
If you look at our company online, you would see mentions like we worked with, for example, and build drills or like Nespresso machines, as you mentioned. And right now we're focusing on what we call AI backbone. So like this AI structure for data centers. One thing that was clear from the business perspective is that you need to focus to really productize your product, because when you work across multiples of industries at the same time, it's really hard to get best business results margin-wise and scale-wise across multiples of industries. And that's how the company started operating across different sectors, from drills to smoke detectors to coffee machines. However, we realized there was a catalyst last year, as you perfectly know, all the interest around generative AI and companies like OpenAI, right? One thing people notice, everybody's excited to use more and more AI applications. But on the other hand, you should always remember that to use those AI applications, you need to leverage infrastructure. And that was a huge change on the market last year. And the attention to infrastructure increased a lot. And since we tackled this bottleneck that depended and that still depends on human labor, and we replace it with smart, flexible automation that can build it in any place of the world, that became so much relevant on the one hand. And on the other hand, we as a company, business-wise, decided to focus, because when you focus, you can improve your business metrics, from gross margin to being able to deliver within short lead times this product to customers, and to many other KPIs and OKRs within the company. It's an exciting time for us right now. At least the last half a year, extremely busy in terms of the ecosystem players and the need for our solution. On our side, we are developing new technology and new products. We'd assembled servers. Now we're assembling data storage. Now we're integrating GPUs and even disassembling them as well.
So, Sviat, Bright Machines had won the 2023 Artificial Intelligence Breakthrough Award for Best AI-based Solution for Manufacturing. Can you speak more to that and what you attribute the success to with this latest breakthrough, or how are they thinking about the future of this market?
AI has existed for some time, machine learning. This new chapter in AI, like generative AI, is just another species, so to say, of AI. And it's going to influence every industry in one way or another. In our case, we've been using what everybody calls AI for the last 5 years, like 5.5 years since the inception of the company. And that's the way we teach robots to be flexible. And we teach them to be adaptable and react and understand what to do fast. Because standard automation is not flexible at all. You just program the robot and it just moves from A to B, for example. What we built is the number of algorithms behind it that navigate the robot. We use the same pipeline for navigation and inspection. And internally, we call our machine learning applications smart skills. And those smart skills, that's the key differentiator. They allow to navigate live using standard equipment like cameras. And then they give inputs to robots based on how they see things and understanding what they need to do. They give inputs like what this particular robot should do at this very moment of time. For example, place this memory module in this part of the server and then clip it, push it down and assemble the server. Like there's a sequence. So this algorithm behind it that we call smart skills, that would be the key breakthrough, as you mentioned. And we productized them exactly last year, I think around summer last year. And right now it's being used in our lines and allows for flexibility that was not possible before, thanks to machine learning and AI.
How has integrating AI into your manufacturing operations led to improvements in efficiency, productivity, and quality?
When you do apply this technology for the assembly process, for example, right? Because it is automated and then you use AI for quality inspection, debris inspection, how it was assembled, of course, you're going to have an impact on quality. So I'll give you an example. If you assemble some kind of electronics, let's take a server, and it's a complex server, let's say it's like 32 memory modules, and you do it manually, what in manufacturing is called first pass yield. The first pass yield is the number of units that go from the line that are usable, like of good quality. So usually first pass yield should be more than 90%. So when you do it manually and it is not an easy thing to assemble, first pass yield could go down to like 60%, which means only 6 out of 10 items of electronics, for example, servers out of the line are usable, like in good quality. Other items, like 4 items, you need to go back to the circle on the line and reassemble to achieve the same quality. So when you use technology that we provide, our first pass yield from what we see is around 98, 99%. So it means like 98, 99 units out of 100 of the line are usable in a good quality. So you just take it out and you can start using. So that's a big differentiator in terms of quality. And of course, if you think about speed, imagine trying to insert like those memory modules and like there's multiples of them and it's dependent on human labor. It's not easy. It's different pressure. You need to find the right place and be precise to do that, right? But when you use robotics and our smart navigation, smart skills, we are super precise and you do it in an automated way. So speed doesn't drop regardless of whether the server is like 16 memory modules or 32. It, of course, can decrease, but we're not as dependent and as differentiated like on human behavior, because different humans have different hands, for example, right? Different pressure, like they work in a different way. Robotics is standard. So we standardize the speed of assembly as well. And as I mentioned before, we increase the quality. So those items put together create that big improvement that you mentioned in your question.
And how have you applied technology to streamline the supply chain from procurement to distribution?
That's also an interesting question because, when you in a standard way, when you assemble electronics, and if you do it by hand, for example, somewhere in China, like the TV that you have behind your behind you is being assembled somewhere in China or Malaysia by 50 people that are standing on the line and doing it manually. When you do it in a manual way, you don't really collect any data, right? You have multiple components that you need to put together, and those people are just putting it together, and then you receive it and you use it, right? When you use our technology, we trace and track data at each step of the assembly process. And that gives you an opportunity to analyze this data and make conclusions, right? I'll just give you an example. For example, if you use multiple suppliers for some parts of your TV, for example, you have, speakers. You might not know this, but you might use speakers from both Panasonic and Sony. But you have multiple suppliers, they just generic item, you replace it, it's a commodity. But it's hard to track which item is easier to assemble, which item has lower failure rates, and so on and so forth. But when you track data, you can navigate this. So, because we collect data at each step, we do inspection, we do pressure analysis and other things, we can tell you and your supply chain management that out of those 3 suppliers, those 2 work perfectly and their failure rates are minor. And, the quality of assembly is always great. But the third one, 7% of cases, it doesn't clip and we need to run another circle and it creates some problems when you do the assembly process. And the company can decide to change the supplier. That's literally like what we saw with one of our customers for one of the components. And that is exactly based on the data analysis that you can gather, data and analyze it after during the process of automated robotics assembly versus human manual assembly.
To that end, then, developing AI infrastructure presents unique challenges, as we both know. Could you share some of the obstacles you've faced in rolling out AI infrastructure assembly solutions for your clients, and also the strategies you've implemented to overcome these hurdles?
As you can imagine, like every time you implement and deliver something new on the market, it takes a little bit of time to understand what it is and how to use it, right? You can imagine every disruption in the world. It took some time to start using Uber instead of taxi, or when Tesla launched and people were used to driving Fords and Cadillacs, and now Tesla is really popular. So I would say there's always time to explain and educate the market. But as soon as you do that, everything goes so much faster. So I would say 2 big things. One, as I mentioned, education. And that's what we are doing, like educating the market and educating the ecosystem of the new solution, of the potential of the solution and the results the solution could bring to the table. And we just discussed with you like the quality, improved quality results, traceability of data, applying software and AI to manufacturing to improve that, and so on and so forth. That's one. But second, it's the demand. So the companies should have a problem to solve. And that problem is dependency on human labor, supply chain risks, geopolitical risks, because right now it's harder and harder to assemble in other countries and then transport, because you perfectly know what's going on around the world, right? We have like multiple ongoing conflicts. For example, if you use Suez Canal, right now it's not safe to go in terms of logistics. So more and more companies are motivated to reshore or onshore their supply chain and production closer to the country where you're going to sell it. Like, for example, building factories in Mexico to serve the US, or building factories in the US to assemble products within the United States to sell for the United States. So this is the demand one. And then you also want to, as we discussed with you, remove dependency on humans and remove that bottleneck. Because if you think about current demand for AI applications that generate demand for AI infrastructure, the problem is not that you don't have enough GPUs in the market. You could have more GPUs, but you're dependent on your supply chain to assemble those GPUs, and you need to tackle this problem. So those 2 things, on the one hand, you need a problem to solve and demand from the market that we see right now, and that's the catalyst that happened last year. And on the other hand, you need to educate the market about your solution and why applying your solution based on AI and software and robotics is solving this problem. So when you have those 2 things, one thing you are directly invested into is education as a company, right? The second thing is outside market that we just see. But when you put those things together, that's when you see a great synergy and you see inflection point for the AI application onto manufacturing. I would say AI and robotics, because we're not just the software company. We bring the full stack solution, software plus automation robotics that does the assembly.
Are there any strategic partnerships or collaborations that have been particularly effective in enhancing your AI capabilities at Bright Machines?
I mean, we have several. I cannot announce just yet a few because we're in the process of closing them, but we just joined on Monday. There was a press release. We just joined the Alliance for OpenUSD. This is an alliance created by NVIDIA, Pixar, Autodesk, Adobe, and Apple. And the idea is that they create a lot of open standards for USD as a format for like 3D. And we bet heavily on the fact that you can virtualize the full ecosystem, the full process of your supply chain from like components and then assembly of those components and even disassembly, right? And to do that, we need a 3D environment. And that's why we joined this alliance, because it's going to help us a lot. We're super excited to start working like in this 3-dimensional process of virtualization, as well as design of the products, because you can design a product in advance to be easily assembled on our lines. Because right now, the products, when you design electronics, for example, that TV that you have in your room is designed for people to assemble. So it had some connectors or wires that it's really hard for robotics to do. Why? Because historically, you've always used human labor to assemble this. So the designers, engineers, they design it for humans to assemble. What we're developing right now, we're going to launch this solution end of this year, is what we call design for automated assembly. It's when you use design tool and we have a plugin, so to say, we give you feedback. Next time you design, let's say your TV or a server, we're going to say that, if you put this connector here or this wire here, it would be easier for a robot to assemble it. And you can just launch it on our lines. And for this, we also need 3D. And that's why, again, it comes back to this Alliance for OpenUSD that's going to help us navigate and create this design for automated assembly solution, because you're going to work in 3D and test it in 3D on our virtual lines to be able to design a product that is potentially 100% automated in terms of assembly in the future.
For people out there like me who don't know too much about the 3D process and are just listening to this podcast to learn more about AI and machine learning, how long from start to finish would you say the 3D process takes? What teams are pulled in to make this vision become a reality, and how long does it typically take?
Yeah, I think we are at the beginning of the journey, the design for automated assembly. Since we're going to launch it end of this year, Q4 this year, I'm going to have a better answer for you end of this year. But if you think about what I can tell you, we already have a solution to introduce new products. For example, when you in a company design a product, let's say, take any electronics you want, a new laptop, right? In our case, we mostly focus on AI infrastructure, so we can take a server. But when you have a new server in your hand, usually it takes a lot of time to teach different lines around the world how to assemble it, right? Because you have different facilities. You can have a facility that builds those servers in China. You can have a facility, in India, another facility in Mexico, a third facility in Romania. So you need to teach how to assemble them, to teach those people, travel around the world. What we do, we take this sample and create a 3D model within 4 hours. And then we create what we call a recipe. It's like the process of assembly. And it means that after 4 hours, when you give me your server, I can already, thanks to 3D, by the way, we create this point cloud, you can run it on our lines within that short amount of time. And right now, that's how we launch new products on our lines, but from the same family. That being said, I'm saying you cannot assemble server and washing machine on the same line, or a laptop and a huge TV on the same line. It's different sizes, different electronics, but within the same product family, you can take multiples of servers. You create this 3D model within a few hours, create a flow of assembly, and start. I think it answers partially your question. For the design phase, I would tell you better next time we chat, maybe end of this year.
What strategies does Bright Machines employ to drive innovation and efficiency through AI within your operations and ecosystem companies?
Again, related to how we use machine learning and AI for our robotics products, like for navigation and inspection. That would be the key use case, because that's our know-how. I think in the future, we also envision, and we're going to apply AI for things that we haven't applied it to yet. But because we collect all the data in the process that was previously not collected because it was humans who assembled things, right? But now when you automate it, you have data points. So each step of assembly, the quality points, product points, points like how robotics operate. So the more data we have, and we can collect them from all our lines around the world, around the footprint. And we have more than 100 microfactories deployed already. Based on this data, we can build models and generate valuable insights. So we plan to do that. And for this types of data, we can apply generative AI in the future. So that's in our roadmap too. But I would say right now, our focus is on what we discussed with you about smart skills and the way we navigate and inspect. And we use machine learning for that. In the future, we can also use AI applications for improvements, leveraging data that we collect from our processes, microfactories, and so on and so forth.
For those out there who don't know what a microfactory is as opposed to a standard manufacturing plant factory, could you speak more to that?
It's just our terminology. If you look at how our lines look on the floor, they would consist from multiple bright robotic cells. It's like a box, like you can imagine a big fridge. And we put multiples of those boxes together. Each box, like our BRC, bright robotic cell, is focused on mostly one, what we call skill. It's an action that this robotic cell is doing. For example, pick and place, or screwing, or soldering, or maybe adding a sticker or something like this, right? And then you have all your process. Let's say you put 10 robotic cells together, and then this is a process of assembly. Imagine when you assemble something, you put, I don't know, think about Lego. You put one Lego box on top of another Lego box, right? That's kind of similar. Like it was just not a Lego, but like you're assembling, I don't know, a server or a laptop, something like this. And then you have multiple steps in this process. And those steps are covered by different robotic cells. And when you put them all together, that's what we call a microfactory. Why it's micro? Because it's like just multiple fridges put together. It's not the full factory. And it's scalable, so you can add those cells or take them out when you need to do changes to the process, right? And it's really easy. And yes, and it's driven by our software, by our secret sauce. Like the same software, the same platform collects all the data, orchestrates automation, navigates the robots, the whole process, and so on and so forth. And this microfactory have multiples of steps. You put the product in the beginning of the microfactory, it's getting done and assembled. And then out of the end of the line, you take a ready product to use.
Looking forward, how do you see the role of AI evolving in the manufacturing sector? And what steps is Bright Machines taking to lead in this rapidly developing field?
Yeah, it's a great question. I think, as we discussed, we touched on it a little bit. The more you go into the future, those industries who were touched less by technology, including manufacturing, they're going to adapt it more and more, because you see more and more value. And more than that, there are like so many drivers that drive you to adopt technology. As we discussed with you, you need more compute on the market, you need more GPUs on the market, and you need to solve bottlenecks in the supply chain. So more and more companies look into this. How we take advantage of it, I would say we've been doing it for 5.5 years now. And we just, seeing all the momentum and doing our best and taking every opportunity to improve the market. And also the way we position ourselves on the market. We are independent and we don't want to replace anybody. We want to partner with everybody and improve the ecosystem. So we can work with, contract manufacturers. We can work with companies that design chips. We can work with cloud service providers and so on and so forth. We work with everybody to improve the technology and supply chain and get access to data and technology that I didn't use before. And I think we're in such a great place, and we're going to continue doing and following the same strategy in the future.